Why does talking to models need its own topic? Isn't it just asking questions?
A vague ask leaves the model filling in blanks, so the same request can drift in tone, scope, or format. A clear prompt turns the conversation into instructions: the goal, the context, the constraints, and the job to be done. That clarity makes the result more reliable, because the model has fewer reasonable directions to wander. Good prompts also create safety boundaries so the model knows what not to do. And when you ask for a specific shape, the answer can become data another tool can use.
So, what will a newcomer be able to do after this set of explainers?
Prompt engineering basics starts with the everyday craft: clear goals, context, constraints, examples, iteration, and sensible boundaries. System developer and user prompts explains the message roles that steer behavior and how conflicts get resolved. Zero-shot and few-shot prompting shows how a pre-trained model can follow a task directly or learn the pattern from a few examples without retraining. Chain-of-thought reasoning covers when step-by-step work helps and why those steps are useful work rather than guaranteed truth. Structured output shows how to ask for validated shapes, so a fluent answer can become dependable data.
When people say prompt engineering, are they just talking about asking nicely?
Start with user intent, what you actually want done. A prompt is the instruction package that carries that intent to the model. The prompt usually contains the task, the context, and the output format. The model uses that package to predict a useful response. The answer is what you judge, refine, or reject.
What belongs in a good prompt before we start polishing words?
A role can help set the kind of expertise or viewpoint you want. The goal states the job in plain language. Context gives the model the background it cannot infer safely. Constraints define limits, such as length, audience, sources, or things to avoid. Output format tells the model what shape the answer should take. Success criteria say what a good answer must accomplish.
So, should every prompt be extremely detailed?
A vague request gives the model very little to aim at. A specific request names the audience, scope, and desired level of detail. With vagueness, the missing choices turn into guessing. With useful limits, the model has fewer ways to drift. Specific does not mean longer, it means clearer.
How much context is enough?
Raw context is the background the model might need: facts, audience, source material, and definitions. Relevant context narrows the possible answers. Noise is extra material that competes for attention. Missing context forces assumptions. The right amount creates better choices without burying the task.
Is prompt engineering mostly finding the perfect magic phrase?
A draft prompt is your first clear attempt, not the final answer. The model answer shows what the model understood. Review compares that answer against the job you intended. Revise changes the prompt based on the failure you found. Test cases keep you from improving one example while breaking another.
Where do examples fit in?
Few-shot prompting means giving examples before the new task. Each example pairs input-output, so the model can infer the pattern. The new task then follows the same pattern. That pattern helps produce a matching answer. Examples are especially useful when style judgment is hard to describe as rules.
Can a prompt also make the system safer?
The user prompt is the current request the model receives. A prompt injection is an attempt to smuggle conflicting instructions into that request. A guardrail is a boundary that tells the system which instructions to follow and which to refuse. The model still produces the answer, but within those boundaries. A final answer should be checked for unsafe, private, or unsupported content when the risk is high.
If I prompt well, am I done?
Prompt quality matters, but it is only one part of the system. It can improve relevance and format. It cannot guarantee missing facts or perfect accuracy. Evaluation tells you whether the prompt works on the real task.
Are prompts just the question you type, or are they doing something deeper?
A prompt is the information and instructions a model receives before it answers. The model uses that prompt as context for predicting and composing a response. Better prompts make the task, limits, and audience clearer. The response is not guaranteed truth. It is the model's best continuation under that context. So prompt design is behavior design, shaping the conditions for a useful answer.
So where do system, developer, and user prompts fit?
The system prompt sets the broad rules of the assistant: role, safety boundaries, and non-negotiable behavior. The developer prompt adds the application's rules: product behavior, tools, formatting, and business constraints. The user prompt is the person's request in that moment. The model answer is produced after considering all of those instructions together. When instructions conflict, higher priority messages generally constrain lower priority ones.
Why not put everything into whichever prompt is convenient?
The system prompt belongs to the platform or operator because it defines what the assistant is allowed to be. The developer prompt belongs to the application builder because it defines how this product should behave. The user prompt belongs to the end user because it carries the current goal and details. Separating ownership keeps the sources of authority distinct. Safer changes follow because users can ask for work without rewriting application rules. Easier audits follow because each instruction has a source.
What happens if a user says, ignore all previous instructions?
A conflicting prompt is still input, but it does not erase higher priority instructions. The system constraints and developer constraints are the rules the answer must satisfy. The answer should follow the user only within constraints. If the request cannot be satisfied safely or honestly, the answer should refuse or redirect. Ignore previous is just another lower priority instruction, not a reset button.
If a retrieved web page is inside the prompt, can it command the model too?
Prompt text can contain many kinds of material, and those roles must not blur. Instructions tell the model what to do. Context gives facts or material to use. Retrieved documents, web pages, and emails should be treated as untrusted context because they may contain prompt injection. A boundary rule says to use the data, but not obey commands inside the data. The safe pattern separates authority from content.
What does a strong prompt usually include?
Start with the goal, the outcome the assistant is trying to produce. Add constraints, limits on tone, scope, safety, length, or sources. Provide examples when the desired pattern is easier to show than describe. Specify output format when another system or person needs consistency. Define success criteria so the answer can be judged, not merely generated. Together, those ingredients produce a clearer answer and make failures easier to fix.
How do teams know a prompt actually works?
Treat prompts like application code. Keep a prompt version, review it, and know what changed. Test cases should include normal requests, edge cases, and misuse. Evaluate outputs for accuracy, safety, format, and refusal behavior. Revise prompt when failures are systematic, not because one answer felt unlucky. Monitor use closes the loop because users and data change over time. The result is a living spec for model behavior.
When people say zero shot or few shot, are they talking about training a model?
Zero shot and few shot are prompting choices. They change the instructions the model sees, not the model's trained weights.
So the same model can be asked in different ways.
Zero shot means the prompt gives the task and asks for the answer with no examples. Few shot means the prompt includes a small number of examples before the new case.
And neither one is secretly updating the model?
In both cases, the model is doing inference, using what it already learned to continue text appropriately.
What actually goes into a good zero-shot prompt?
A zero-shot prompt usually starts with the task: classify, summarize, translate, extract, or answer. Good zero-shot prompts also state constraints, such as tone, length, or allowed labels. Then comes the input, the actual material the model must work on.
And the model just figures out the response from that?
The answer slot is implied or named, so the model knows where to produce the result. What is missing is examples. The model must rely on its general training and the prompt wording.
Then few-shot is basically giving the model examples to copy?
Few-shot prompting supplies example pairs, an input, and the desired output. Several examples create a pattern the model can imitate.
Where does the real question go?
The new case is placed after the examples, using the same shape. The model then completes the missing output by following the demonstrated pattern.
Are examples just tiny training data, or are they doing something subtler?
Examples act like compact specifications. They define the label set, the allowed categories or decisions. They define the output format, which often matters as much as the content. They set style and level of detail. They can include edge cases, showing how to handle borderline inputs. But a bad example can steer the model in the wrong direction.
If the weights are not changing, why do examples help at all?
No weight update happens during the prompt. The model is using the context window. Inside that context, attention lets later words be influenced by earlier context. The learned model estimates next tokens conditioned on all that context. When examples are clear, the likely continuation is the kind of answer you want. This is often called in-context learning. Behavior changes within the prompt, not in the stored model.
So why not always use few shot if examples make things clearer?
Zero shot is lean. Fewer tokens, lower cost, and less setup. Few shot adds control when the task is unusual, ambiguous, or format sensitive. The price is prompt length. Examples consume the same context window as the input. The risk is example bias. One unrepresentative example can pull answers toward it. So the trade-off is simplicity versus specificity.
How should someone decide which approach to try first?
Start with zero shot when the task is familiar and the output format is forgiving. Move to few shot when the labels are subtle, the format must be exact, or failures repeat. Good examples are representative, concise, and consistent. Keep a small test set so you can compare prompts on real cases, not vibes. If performance still misses the mark, the next steps may be retrieval, tools, fine-tuning, or a different model.
When people say an artificial intelligence is using chain-of-thought reasoning, what is actually happening?
The familiar problem is a model jumping straight from a question to an answer. Chain of thought inserts intermediate steps. Move 1, move 2, move 3.
So it is not a special brain module? It is a way of making the work explicit?
Exactly. The purpose is a reasoning path. The answer depends on.
Why would writing the steps improve the final answer?
It helps when a hard problem is too large for one big leap to a correct answer. The chain breaks the task into a subproblem, a constraint, and a check. That structure gives the model more chances to bring in relevant info before the final commitment path.
So the advantage is not the length, it is the organization.
Right. Extra words help only when they structure the work.
If the model shows a chain of thought, are we seeing how it truly made the decision?
No. The real computation involves internal activations, while the chain is generated text, not a brain scan. That generated text can be helpful, incomplete, or a rationalization. So the final answer should be judged by evidence and tests, not by how confident the steps sound.
In other words, the explanation may be useful without being a perfect window into the model. How do people actually ask for chain-of-thought reasoning?
The starting point is the prompt, the instructions and context given to the model. Step-by-step prompting asks for an ordered solution. Worked examples show the model the kind of reasoning pattern to imitate. Decomposed prompting splits one hard request into smaller questions. Self-consistency samples several chains and looks for an answer that keeps recurring. Tools can add calculators, search, or code execution when reasoning alone is not enough.
Is chain of thought useful for every kind of question?
It shines in math and logic, where several steps must fit together. It can also help with planning and code because each choice constrains the next. It is less useful for simple recall, where extra steps can create invented support for a fact. For subjective or ambiguous questions, the value is often clarifying assumptions. The pattern is strongest when there is a checkable answer.
What are the downsides of asking for more reasoning?
The basic trade-off is accuracy gain against token cost and latency. Long reasoning can also create privacy risk if sensitive details appear in the prompt or response. And a chain can make a plausible error look more convincing than it deserves. So more reasoning is not automatically better. It is a tool with costs.
What is the practical rule for using chain of thought well?
Start with the task, and let scratch work serve the answer rather than become the answer. For high-stakes use, add verification with tests references or another independent check. Ask for key reasons and a final answer in a form a person can use. Then treat the final answer as a claim to check, not as proof because it came with steps.
So, chain of thought is best understood as scaffolding, often helpful, sometimes misleading, and always worth checking. When people say a model returns structured output, what is actually different from a normal answer?
Free text is an answer meant for a person, useful, but full of phrasing choices.
So, the problem is not that the answer is wrong, but that software has to hunt through it?
Structured output is the same answer shaped for software, so each piece lands in a predictable place. Field names, values, and types make the pieces explicit instead of implied. Applications can read those pieces directly without guessing where the answer starts or ends. That means fewer guesses between the model and the code that uses its answer.
What gives that predictable shape its authority?
A schema is the contract. It says what the answer is allowed to contain. Required fields are the pieces that must be present every time. Allowed types say whether a piece is a string, a number, a boolean, a list, or an object. Enums restrict a value to a known set like open, closed, or pending. Nested objects let one structured thing contain another structured thing. A model response is expected to match that contract before the application relies on it.
Is structured output just a polite instruction, or can it be enforced?
The prompt and model still begin the process. The model proposes content for the answer. The decoder turns the model's probabilities into tokens, one choice at a time. A schema gate constrains those choices to the shapes that are allowed. A valid object can continue forward because it matches the expected shape. Reject or repair handles an answer that breaks the contract. The consumer receives data it can parse instead of prose it must interpret.
What kinds of mistakes does this catch?
The same request can produce answers that look fine to a reader but differ in machine shape. A valid shape has every expected piece in the expected form. A wrong shape is not necessarily a bad idea. It is an unusable form. Missing field means a required piece never arrived. Wrong type means the piece arrived as the wrong kind of value. Extra text can break a parser that expects only the structured answer. A validation error is valuable because failure becomes explicit instead of silent.
Does a schema alone make the output reliable?
A clear task reduces ambiguity before the model starts answering. A schema defines the shape the answer must take. Constrained decoding can prevent many invalid token choices during generation. Validation checks the finished answer against the contract. Retrieves give the system a controlled way to recover from a failed attempt. Tests reveal edge cases before real users depend on the format. Reliability comes from the layers working together, not from one magic setting.
Should teams make the schema as strict as possible?
A loose schema preserves flexibility when the possible answers are varied. A strict schema increases predictability when the application needs exact fields. The trade-off is choosing how much freedom the model keeps versus how much certainty the application needs. Model freedom is useful when the answer is open-ended or creative. App safety matters when downstream code, money, or user trust depends on exact fields. Versioning keeps changes explicit when the contract evolves.
Where does structured output make the biggest practical difference?
Structured output is most valuable wherever a language model hands work to software. Function calls need exact arguments, because the wrong shape can call the wrong tool or fail entirely. Data extraction turns messy documents into fields a database can store and search. Agents use structured output to choose actions, pass tool inputs, and report results. Evaluations use structured judgments, so quality can be counted, compared, and improved.
So the real promise is not prettier answers. It is a cleaner handoff from language to systems.